Hello, West Platte 6th graders. Mrs. Parsons here with your next video and lesson in mathematics covering GCF and LCM. Now, when I say those two things right away, you're probably asking yourself, well, what's GCF and what is LCM? I'm going to explain those acronyms to you today from mathematics, but I'm also going to let you know that I bet, and I almost promise you, that you have used GCF and LCM in your prior learning throughout elementary school. You just may have called them something different, or you may have used a different process to work them out. So let me begin with telling you that these are acronyms on the back of the board here, GCF and LCM. And remember, acronyms are letters. You take the first letter of the word of something you're trying to describe or you want to share with someone. And in this case, I'm using GCF and LCM. And that GCF come from this lovely known thing in mathematics called greatest common factors. So GCF stands for greatest common factors. And the LCM is least common multiple. So here it states least common multiples. Both of those are math processes in not just 6th grade, but in mathematics in general. And they inform you of things that you will use to help you solve other mathematical problems. So I'm going to take a look at what GCF and LCM stand for. I took those acronyms, I broke out those processes in math, and then I took back some important words that you need to remember from those two items. GCF, known as greatest common factor, 6th graders, has the word greatest, common, and factor in them. And so when you think of greatest, I'm hoping in your mind you're like, oh, greatest means, let's think in mathematics terms. Greatest to you might be the greatest movie you've ever seen, the greatest book you ever read, the greatest present you ever received at Christmas or Hanukkah or any other holiday, birthday that you celebrated. So those things, ladies and gentlemen, greatest are what gives you an intrinsic feeling. In mathematics, greatest means the largest or the most value when we talk about numerical items. So greatest, of course, in mathematics is the largest. And for us, we're thinking largest as in numerical value. Numerical value. That is what greatest means to us in mathematics. So when we think about greatest common factors, we're looking for the greatest number we can receive. So in the next term, it talks about common. Well, for you, I'm trying to think of a good instance where you would say, well, that's just not common. Maybe if it rained a lot or we got a ton of snow, you might say, well, that's not common for the state of Missouri. Or if you received homework every day in all of your classes in the 6th grade, you might say, well, that's just not common. Our teachers don't give us homework every day. So what you're looking for in common is, what do you have alike? What are you used to? What is consistent? So common means alike. So the same. When you're looking for common, you're looking for things that happen, things that happen the same. Well, then the last word of GCF, or the last meaning of GCF, is the word known as factor. Now, we've already discussed this. So right now, I'm hoping you're saying to yourself, wait a minute. Greatest common factor. I know what greatest is. I know what the word common means. And I know what a factor is. Maybe I could figure out what greatest common factor is in mathematics, and maybe I could use it. Maybe I've already used it. So factors, of course, you know, are the digits or numbers used in a multiplication problem. I hope you can read that. Kind of looks pretty messy. A multiplication problem. So factors, 6th graders, are the numbers you use in order to solve a multiplication problem. Here's a factor, here's a factor. An example, 7 times 9. What are the factors? 7 is a factor and 9 is a factor. They're the digits or the numbers we put together through the multiplication process in order to find I bet you're saying it, in order to find the product. That is what factors are. And that is what GCF stands for, greatest common factor. And when we look at that, sixth graders, I'm going to give us an example. Greatest common factor. I want to use the number 14. So when we think of 14, we think of all the factors that make up 14. 1 times 14 gives me 14. 2 times 7 gives me 14. And then I ask myself, is there any other numbers that will give me 14 when I'm multiplying them together? And I'm hoping in your head right now, you're saying, well, no, I don't know anything else that makes up 14. And if you recall, you actually probably used this in the 4th grade, but your teachers probably called it a T-chart. And they gave you the number 14 here, and they always said, start with 1 and find out what times 1 would give you back 14. And you said 1 times 14. And your teacher then told you, don't skip any numbers, just go right down the numerical order and see if there's anything else that you can multiply together to get 14. So then you said 2 times 7. And then you ask yourself, is there anything times 3? No. Anything times 4? Until you got back to 14, because 14, sixth graders, must be the largest factor you use to make 14. 1 times 14. That's the greatest factor when you multiply numbers together that give you 14. Now, what Mrs. P means by greatest common factor is that we're going to not just use one number to find the factors, we're going to use 2 numbers. So here's an example. I want to find the factors, and I'm going to erase this and start all over, for the number 14 and 49. And so what I start to do is I look for all the factors that make up 14 and make up all the factors of 49, or all the factors that make up the product of 49. So I'm going to start again with 1 and 14, 2 times 7, and then I look to see if there's anything in between here, between 2 and 7, that if I multiply them together will give me 14. And I know there's not. So those are all the factors for the number 14. I then want to see all the factors for 49. So I start with 1 and 49. I don't skip any numbers. I always start with 1, and then I just go down the numerical order to see if there are any other numbers that will make up 49. So I go to 2. Is there anything times 2 that gives me 49? I don't know any. Is there anything times 3? Again, I don't know any. Is there anything times 4, times 5, times 6? You keep going until you find one, or you keep going until you're like, there are no more before I get to the number 49. So I know that 2, 3, 4, 5, 6, nothing times those will give me back 49. But I know 7 times 7 will give me 49. And I don't really even have to write it twice, sixth graders, because this will tell me that I'm using 7 twice. If I cannot find a pair, a match for it, I know that I've used it twice. And then I tell kids, I love to rainbow it out. Your teachers in the 4th grade use a T-chart. It's the same thing. They called it a U-turn. You went 1 to 14, 2 to 7, and they said U-turn. How do you get from here to here that gives you back 14? Well, Mrs. Parson likes to say it's a rainbow. 1 times 14 connects in my rainbow. 2 times 7 connects in my rainbow. And then I know that those 2 factors make up my product, and I haven't missed any factors. And then I know I've got all the numbers that I can use. And in the instance with 1 and 49, they're a pair. And then there's no other pair, so that must mean that 7 was multiplied by itself to make it a set of factors that gave me back 49. Once I'm done finding all those factors, I just look for the number that they have in common. I look for the greatest number that 14 and 49 have in common. What is the greatest number that is the same between these two factors or these two numbers. And if you look, sixth graders, I see a 7 here. I see a 7 here. So the GCF must equal 7 because the number 14 and 49 have 7 as a common factor, and it's the largest, the greatest factor they have in common. That's your greatest common factor, sixth graders. Boom, done. And you have to use those when you're doing certain problems, when you're trying to simplify fractions, when you're trying to figure out how many hats and cups and plates you need at a party. This is your introduction and really your revisit to greatest common factors. I am now going to explain least common multiples. So I'm going to go back to my opening page because I want to put the definitions on here. I'm going to change my color to blue. And we're going to talk about least common multiples. And I said that it was LCM, least common multiples. And it actually is, I want to say opposite almost for you. In greatest common factor, you look for the two numbers that you put together that'll give you back that product. What two numbers do I multiply together, sixth graders, that give me the factors, or what factors do I use that give me the product of 14? Well, we just said the factors we used for giving us the product of 14 was 1 and 14, 2 and 7. The difference between that and least common multiples are, sixth graders, your multiples are actually your products to those factor answers or factors solutions. So 1 times 14 gave me 14. That's the first multiple of 14. 2 times 7 gave me 14. Those factors then gave me back 14. But if I want to go down the line and use every numerical number in our number system, what I will get back are known as the multiples. They're the actual solutions, the answers, the products to our multiplication problems. So least, ladies and gentlemen, in this case, means the smallest, which is your numerical value. So least is your smallest numerical value, sixth graders. Common isn't going to change. Least common multiple is, it's still what multiple is the same in the problems that you're trying to figure out. So common means the same. And in this case, multiple, sixth graders, are actually your solutions, and I'm going to tell you they're known as your products, to your multiplication problems, to your multiplication, I left a letter out, multiplication problems, or what you might want to call your facts. And I'm writing them really small, so I'm going to read that to you again. So least is your smallest numerical value that is the same when you find the solutions or the products to your multiplication problems or your multiplication facts. And I'm going to show you an example of that as well. And sixth graders, I'm actually going to use the two numbers I already used in our GCF. So if you recall, in our GCF, I used the number 14 and 49. Now, I will also let you know that multiples will go on forever. Factors will not. And I'm going to show you that back when I finish showing you multiples. So multiples, as I just told you, are the actual responses, the solutions and answers to your multiplication facts. After you put two factors together and you get a product, those are your products from your multiplication facts. So you always, again, you can start with 0, sixth graders, but we know anything times 0 is always going to give us back 0. So I always tell students it's best to start with 1. And what I mean by that is you just said 14 times 0 is 0. That's a multiplication fact. That's the product you get from it. Then we're going to do 14 times 1, and that gives me 14. 14 times 2, and that's going to give me 28. 14 times 3, that's going to give me 42. Oopsie, I put a comma there. Sorry, I'm in a multiplication sign. Then I'm going to go on to 14 times 4, and that's going to give me 56. I'm then going to go on to 14 times 5, and that's going to give me 70. And then I'm going to go on to 14 times 6, and that's going to give me 84, and so on, and so on, and so on. Sixth graders, these things you see right here are your multiples. It's like your repeated addition, but every time when you're repeating that, you're adding on 14 every time. In this case, because I'm using the number 14. So you've used this in real life when you did something like this. And I'm going to do the whole thing for you because it's fun. Ready? You've used multiples when you did this. 2, 4, 6, 8. Who do we appreciate? Blue Jays. Blue Jays. Go Blue Jays. Those are your multiples, sixth graders. Whenever you walked around a classroom and you said to your teacher, 2, 4, 6, 8, who do we appreciate? Mrs. Conrad, Mrs. Conrad, yay, Mrs. Conrad. Those are your multiples. They are the products of your multiplication facts. 2, 4, 6, 8 were the products of 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. When you did those, ladies and gentlemen, 2 times 1 gave you 2. 2 times 2 gave you 4. 2 times 3 gave you 6. 2 times 4 gave you 8. That's where you got the 2, 4, 6, 8 from. It's the same with your 5, 10, 15, 20, 25, 30, 35, 40. Every time it's repeated addition where you're adding on 5 each time. But really, sixth graders, your multiples are the answers to your multiplication facts. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And you should be able to do that with any number ever in the mathematical number system. So it doesn't matter what number you give, you should be able to find the multiples of them because you can multiply every number by the next number, such as 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So what are the multiples of 8? 8, 16, 24, 32, 40, 48, and so on, and so on, and so on. Your multiple sixth graders are the answers to your multiplication facts. They're your products that you get. And when we talk about LCM, we're actually telling ourselves, can we then find a multiple that numbers have in common? And we want it to be the smallest multiple. So when I look at this sixth graders, and sometimes you might find it really quick, and other times it might take you forever to find them. And so when I did that, I said I was going to use 49, but I'm not actually going to use 49. Instead, I'm going to go back because it'll be easier for me to get into the video. I'm going to use the number 7. So, of course, I'm going to start off again. I'm going to go 7 times 0 is 0. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And so on, and so on, and so on. And when we have these two numbers, and I ask you, what is the least common multiple? We're looking for the smallest number that is alike, that is a multiple of these two numbers. Well, 0 and 0, yes, it is the smallest, but 0 goes to any number. If we went with 0, every number would just be 0. And since we know 0 really doesn't have a value, we always really want to go with our numbers that start with 1 times something. 1 times something. And in this case, we go 1 times 7 is 7. 1 times 14 is 14. Well, those are small numbers, but those are not like. They are not alike. So we go to the next one. We got a 14, we got a 28. We got a 7, we got a 14 right here. Wait, I see, ladies and gentlemen, that this 14 is the same number as that 14, which means I've already located a least common multiple. I have located a small number that they both have alike when I'm thinking about their multiples. Now, they may have other multiples that will be alike when we go further down, but you always want to pick up the smallest multiple that they have in common. And in this case, it's 14. And that is what least common multiples are. They're the actual products of your multiplication facts. And so a few things I want to reiterate to you as we open up this introduction. Greatest common factor stands for the greatest number, the factor, that a set of numbers has in common, which is that they have alike. And so you're looking for the largest number that you see that two or more numbers have in common. Two or more numbers have that look alike. Least common multiple is the smallest number that they have alike when you think about their multiples. Factors, ladies and gentlemen, will end. When we look at this, factors aren't going on forever and ever and ever. Only certain numbers that you put together will give you back a product. And in this case, for 14, there's one set of numbers and two set of numbers, which means two set of factors that make up 14. For the number 49, there was one set of numbers and two set of numbers that made up the product of 49. And when we looked at those two products, those two numbers, and we looked at their factors, we found out that the largest one they have in common is the number 7. But they will not go on forever. Numbers times numbers, or factors multiplied by other factors, won't go on forever. Only certain factors, when you put them together, will give you back another number. Multiples, on the other hand, sixth graders, will go on forever and ever because we know the number system never ends. So I can multiply 14 times 1, times 2, times 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can go on and on and on multiplying numbers by 14. Now they're going to get big, but I can do it forever. And that's really a great way to tell the difference between factors and multiples. Factors will eventually come to an end. Multiples will go on forever. Factors are the numbers you use to find your product. Multiples are the products from the numbers that you used to find that solution. So hopefully that's a great introduction for you on GCF and LCM. You have used them before. You have talked about them, discussed them in prior knowledge. And that is what we're going to work on this week. We're going to locate GCF and LCM in numbers and in word problems. So that is what we'll work on this week. And until the next time, Mrs. P is wishing you a very happy day.